In this video, we will discuss about the domain or the set of all possible values of x in rational expressions. Okay, so when we say permissible, it means all the possible values for x, any number that can be substituted to x that will make the whole rational expression valid. When we say non-permissible, these it is the restriction. So what will be the values of x that will make the whole rational expression undefined? So since these are rational expressions, they are in fraction form. And in fractions, let's say 1/2 and 1/0. In the given, this is accepted or it has a value. Whereas in 1/0, your denominator is 0, which will make the whole fraction undefined. Undefined. Okay, so the restriction here to see the non-permissible values for x, the denominator, the whole denominator must not be 0. So let us see the domain, the permissible and non-permissible values for x. So for number 1, you just get the denominator. Okay, so our denominator here is x. So your x should not be 0. Meaning to say, if your x here is 0, that will be 0 plus 3. So 0 plus 3 over 0. 0 because your x here, if your x is 0. So 0 plus 3 is 3 over 0. So your denominator here is 0, which makes the whole expression undefined. Okay? So your restriction is that your x must not be 0. So if we're going to write the permissible and non-permissible values of x, the x here should be a real number. Should be a real number. So when we say a real number, these are the numbers that are terminating and repeating decimals. Okay, non-permissible is here. Your x must not be 0. So you can substitute any values for x here, provided that your x should not be 0. Okay? Now, this is for number 1. For number 2, again, you take the denominator, x minus 3. Then the whole term must not be equal to 0. So just like in equations, we need to identify the value of x. So we have to transpose this to the right to combine the two constants and to get the value of x that is restricted. So when you transpose this, x will be left for you. Then you have here 0. Transposing minus 3 to the right will give you plus 3. So 0 plus 3 is 3. So the restriction is that your x must not be 3. So again, if you're going to write it here, so for the permissible, again, all set of the real numbers. And for non-permissible, your restriction is your x should not be 3. That's for number 2. Next, for number 3, as you can see, your number 3 has a denominator of 7. So no value for x. Meaning to say, the permissible, all real numbers. Then for your non-permissible, nothing po. Because your denominator is 7, meaning the values of x are only in the numerator. So any value can be substituted to x and can make the whole given a rational expression. So, meaning to say, any value can be given here. Wala tayong restrictions, or there will be no restrictions. Now, what if you're given in the denominator is like this? So, for example, we have here, let's say, example number 4, negative x over x squared minus 9. So here, your denominator is x squared minus 9. So you put your denominator x squared minus 9. The whole term or the whole denominator must not be equal to 0. So again, we take the denominator only half to get the restrictions. Okay, now, in this case, you don't need to transpose this, okay? So what you're going to do is to apply factoring method. So since here we have a binomial, a minus sign here, and your two terms are perfect squares, we apply difference of two squares, in which we put pairs of parentheses, and then we get we put plus and minus, since we are dots. We get the square root of x squared, which is x, so you put that here. And then the square root of 9 is 3. So here we have to get the value of x that is restricted. So in each term, we put not equal to 0 to get the restrictions. So just like what we do, to get the value of x here, we transpose this to the right. Same goes here. So when we are transposing, the sign is changed. So x will be left for you. So 0. Then plus 3 will be minus 3. So 0 minus 3 is negative 3. So your restriction here is your x should not be negative 3. Whereas here, you are left with x, then not equal to 0, then minus 3 will be plus 3. 0 plus 3 is 3. So there is another restriction for you. So for your final answer, the permissible, all the set of real numbers, the non-permissible, your x should not be negative 3, and your x should not be positive 3. So why is that? If we are going to substitute, let's say, negative 3 here, that will be negative 3 squared minus 9. So negative 3 squared means negative 3 times negative 3. That will give you 9, positive 9. So 9 minus 9 will be 0. So your whole term here in the denominator will be 0, which will make the whole rational expression undefined. Whereas here in 3, if we substitute 3 here, so 3 squared means 3 times 3, which is 9. So 9 minus 9 is again 0. So the whole rational expression is undefined.